At the beginning of this lesson, I'm demonstrating for students how to present their transformation from their parent function. And we talk about it can't be a transformation unless it came from somewhere. We talk about how the Hulk transformed from a man into a huge being, but he had to come from somewhere. The new function has to transform from a parent function. And so my parent function is y equals x squared, and I'm just demonstrating a simple transformation of y equals x squared minus 2. So from my parent function, y equals x squared, you can see that my transformation was just down 2. So subtract 2. So that plus k out there was minus 2, and so it's just a shift of down 2. There's no horizontal shift on my new function, and so it didn't shift right or left. All the points just shifted down 2. The key point that I look at when I'm looking at the shift is that vertex 0, 0. I also have my t-table here with my new function, and if you were to compare it to the parent function, you would see that all the y values would shift down to from the original function. Then you're going to look at, now that I have my new function, now I'm going to talk about all the vocabulary associated with the new green function x squared minus 2. So when I look at the domain of that function, it's all real numbers. So the domain is going to be negative infinity to positive infinity. The range is going to be, the lowest value that it could be is a closed interval at negative 2, and then going to infinity is the highest value. If I look at, this is a polynomial, so the degree is 2, and the terms is 1 less than that, so the number of terms is going to be 1. If you look at the increasing and decreasing intervals, if I'm looking along the x-axis, because that's where you look at where it chops the intervals, so you can see that from negative infinity out here till 0, if I look along the x-axis, that function is decreasing. So my decreasing intervals are going to be from negative infinity, just one decreasing interval from negative infinity to 0. Remember, you just represent those with parentheses. There's no interval notation with those. My increasing interval starts at 0, and then look along the x-axis to infinity it goes, and so it increases from 0 to infinity, and again it's just notated with parentheses only. There's no interval notation involved in that. It is continuous. You never lift up your pencil if you're drawing that function. It is a function. It passes the vertical line test. The x-intercepts are between 1 and 2, so to identify those with the graphing calculator, you can either use the trace and find, I can't on here, but you can use the trace or you can analyze it. And when I did analyze that, I found that it was the x-intercepts are 1.41 approximately 0, and the other x-intercept where you see it crossing the x-axis right there is at negative 1.4. It's basically positive square root of 2 and negative square root of 2, 0. And you also could have substituted 0 for y and solved for, if I can demonstrate that, I could have put my equation x squared minus 2 equal to 0 and solve for x. Remember, if you substitute 0 for y, because y is always 0 on the x-axis, you could have solved that and you would have had x squared equals positive 2 when you bring that across the equation. And then take the square root of both sides, so x is equal to plus or minus the square root of 2. And so those are the x-intercepts. And then if you look at the y-intercept, that one's easily seen at 0, negative 2. So the y-intercept is 0, negative 2. That's also the vertex of this function, the key point that we've been looking at. And that's also a minimum value of this function.